Welcome to the Trend Computer Festival. My name is Jack.
I'm Ricky.
I'm Mike. I'm Peter.
And so today we're gonna share with you our senior project. We're gonna give a brief overview of the project and some of the applications of it, and then we'll open up the floor for questions. So we are the ESP32 Room Development Board and API for Android Senior Project Group. And so we'll get started with a brief overview of IoT.
So I'll start us off. So our project is based around IoT, which stands for Internet of Things. So this refers to a network of physical devices that are embedded with sensors, software, or other technology that allow them to connect and exchange information over the internet. IoT products can vary greatly from household items like TVs and a thermostat to electronic devices like mobile phones or laptops. The main goal behind IoT is to have devices communicate and interact with one another in an intelligent manner, thus improving efficiency and economic benefits, while reducing the need for human exertion in controlling the flow of information. IoT applications can be found across various sectors of society, including agriculture, manufacturing, healthcare, and urban development. How do you do that?
Yeah, got it.
Yeah. So our project is based around the ESP32 microcontroller. So the ESP32-WROOM-32E, that's the specific controller we're using, is a highly versatile microcontroller that was developed by Espress Systems and released in 2016. It possesses robust capabilities and applications for the design of IoT products. One of the main parts of the ESP32 are its two CPU cores, which can be operated either separately or together. This enables multitasking and parallel processing, which gives the MCU improved performance in utilizing IoT applications. The ESP32 also has power consumption in mind, with several power-saving features and low power modes enabled that give the user the ability to use battery-powered devices for designing IoT products. The ESP32 is also highly integrated as well, with built-in antenna switches, RF BAW, a power amplifier, a low noise receive amplifier, and filters, and has minimal PCB requirements.
All right, so some of the notable features of the ESP32. It's a very low cost and low power microcontroller. It also has integrated Wi-Fi and Bluetooth capabilities. It has digital input and output pins, GPIO pins, as well as pulse width modulated pins and analog input and output pins. And it also supports SPI, I2C, and UART. So the primary goal of our project is to create a development board around this chip. So having Wi-Fi and Bluetooth capabilities will allow us to connect to our Android app that we're creating, as well as the GPIO pins and the analog pins will help us read in data and also output data. So some of the specifications of our chip, it has a 240 megahertz CPU clock, as well as 448 kilobytes of ROM and 520 kilobytes of SRAM. Integrated on the board, there's an onboard PCB antenna, as well as a 40 megahertz crystal oscillator. For our wireless capabilities, it supports Wi-Fi 802.11 with a bit rate of 150 megabytes per second, as well as Bluetooth 4.2 and Bluetooth low energy. The pins we discussed before, but it has GPIO pins, analog input, and analog output that's supported through the DAC and the crystal oscillator.
All right, so some of the main differences we wanted to highlight were between Arduino and ESP32. Originally, we were using the PIC32, but we found that the ESP32 is way more developer-friendly and relatively same cost, so we switched to the ESP32. The main differences out of these two are, again, the cost for the ESP32 is an industrial-grade chip. we're getting them between $3 and $5 compared to setting up an Arduino, which is a lot more money. And Arduino, it's kind of like more given to you in a sense, where we're making our own development board. So we're also making Android API, which I'm working on. That's close to completion. So the goal of the API is it's being built in Android Studio. It's an Android app. Some of the goals are it has to be able to connect to the chip through the app. And then we want to be able to control user input and output from the app to the chip. So when we print our PCB, we can connect that straight to the app directly without having to use another party. So as listed, some functionality of the application. The dev board will communicate with Android phone through Bluetooth low energy connection. The API will display the input and allow the user control of outputs, and it aids in development of IoT products, like previously mentioned.
Additionally, so because this is our senior project, we want to, show and illustrate that there are real world applications for IoT development. It's, an emerging field currently. And so some of the applications include healthcare, agriculture, asset management, and also some industrial applications, to be integrated with larger systems. And so basically these applications are kind of almost, in the forefront of our mind when we're thinking about when we're designing our board. We're like, all right, what applications is this board and project going to be suitable for? The typical application that comes to mind is, a smart house. So like if you were to have like, a temperature sensor, to control your heating system throughout your house, and smart lighting solutions. And the whole idea is this, using this microcontroller to integrate systems within your house that you can connect with your phone. And it would provide, a nice sort of intuitive infrastructure to control your smart home. In conclusion, basically our project serves as an IoT development board. We're here to design this board so that it can have IoT applications in the future. And we're also trying to provide a cheap and effective solution, something that can be done very little cost and can be replicated and reproduced. Additionally, we selected the ESP32 because of its capabilities. The on-chip antenna is specifically useful for our Bluetooth applications, which allows the chip to communicate to the phone, but also because the ESP also has Wi-Fi capabilities as well. That enables you to be able to, if you can connect to your home network, which is connected to the chip, then you can control the chip remotely from anywhere if you're connected to a web network. And then additionally, we're also working on the Android API as well, so we can control the chip and its behavior and configurations from the Android application. And that's pretty much the gist of our project. Do you guys have any questions?
We're also a legacy project, so the group that comes in next year will continue to develop it even further. Yeah.
But I did do have to through anything about like security for these devices, because if they were to be used in any sort of setting like that, it's just Wi-Fi. Anyone can use Wi-Fi can tap it.
Yeah, so security is definitely something that happens at the modular level of development. So throughout the entire development process, security is definitely in mind. However, it's important that you'll maybe some like tokenization to verify the user on your own network. I mean, most of the time you should keep your home network pretty secure. So unless you're expecting any intruders, I would hope that we wouldn't run into that misuse case. But thank you. That's a good question.
For your when you say you're developing with Android Studios, are you using an Android phone, or are you just using emulation?
We have both emulators and Android phone. It's good to switch between the two. The emulator is really good for while you're development and testing the development. And then once you get to a larger breakthrough in your development process, then we can switch to the phone. and test the functionality.
Yeah, it's just easier to load a new version on the simulator and test on there versus like plugging in the phone, loading it on there every single time.
How far along are you guys with the hardware design? You know, you mentioned something about you're gonna get the board printed. Like, what kind of tools are you using? Where's the circuit?
Yeah, so right now we're working towards, so that's where almost part of the legacy project comes in. So our ultimate goal for this semester is to probably breadboard. So we're probably gonna try and print like a really cheap breakout board so that we can just get the chip mounted on a solution so that we can then breadboard a circuit to flash the chip. And hopefully, you know, if the circuit works, we can then probably put an order for a printed circuit board. That's one of the ultimate goals. In terms of progress, right now we have like the board, and we also have some circuits, but nothing that is like simulated on Eagle. We don't have any Gerber files yet or anything like that.
So what kind of package does the chip come in? That's a breakout board in and of itself, and then, right?
Yeah, so let's go back to right here. So we're just getting the chips
Yeah.
right from that, and so we do have like a solution to currently flash firmware on the board, but it's similar to something like this. But the ultimate goal is to, you know, develop a PCB that has, you know, the bare minimum what we need at a cheap solution so that we can implement it in like a larger scale IoT project.
Another one of the main goals of our project this year, something that is going to be more unique to us, is we're actually writing a tutorial on how to start a basic project using the chip. So working on getting like basic functionality out of it. And at the same time, we're writing tutorials to make it easier for the next group to just get right into making more large scale projects.
Yeah, like I previously mentioned, we were using the PIC32 most of last semester, and there's very little documentation on it compared to the ESP32. So for next year's group, at least, we're fully documenting everything that we did on the software and hardware side, so that they can really, you know, jump way ahead of where we were.
Are you using IDE to flash it?
So we have two current solutions for writing firmware. The Arduino IDE does work and it is compatible to flash it. Also on like Visual Studio Code, there's like a couple extensions, like a platform IO. So we're just a combination of those two to flash the firmware. It depends the specific use case of the project and how extensive the firmware will be, but that's pretty much it. Thank you guys.
Thank you.